You can remember we did the first principles, which was f apostrophe x is equal to the limit h tends to 0, f of x plus h minus f of x over h. Do you recall that formula?
Yep.
Okay, and what was the purpose of that formula? What did it give us?
The gradients of the tangents.
Which is another name for?
I can't recall right now. Sorry, I'm buggered. Today was a long day at work.
That's alright. Do you remember that word?
First derivative, yes. Okay.
Alright. Now, let's say, just to take you through something very quickly. Say you are given f of x is equal to x squared. And you are asked to find the first derivative using first principles. What you'll then do is you say, okay, I already have f of x. Let me go and quickly calculate f of x plus h. You remember this technique? Jason, do you remember this technique?
I remember you showing me, but I think I just need a little
Okay, I said
refresh.
you have to be given that part of the formula. You just need to go and calculate that part of the formula by replacing all the x's with x plus h. And that's simply what I've done there. I replaced that x with x plus h squared. And then I multiplied the brackets out.
Okay.
Alright, and then I feed everything into that formula. Limit of h tends to 0. F of x plus h is that expression there. So it's x squared plus 2xh plus h squared. Then there's a minus, and then I write f of x, which is that part of the question. And this is all over h. And then I also said, remember that everything not containing h must cancel. So you'll find that those two cancel each other out. And you will be left with the limit of h tends to 0. 2xh plus h squared over h. Do you remember what the next step will be?
You can take a common fact. You can take out a common factor, the h.
Yes. Alright, which then means
that you can cancel the h's on the, yeah.
Okay. And then whatever h's remain becomes 0. So you will be left with 2x. And 2x is then the first derivative. You happy with that?
Yeah.
Now with even a simple formula, simple equation such as x squared, it took us a few lines just to get the first derivative. Now imagine if you have something like this. How long do you think that's going to take?
Long. Really long.
So there must be a quicker way. Do you agree?
Yeah.
Alright, and the quicker way is you multiply the exponent with the number in front. That's step 1. And then step 2, you minus 1 from the exponent. So let's do that quickly. 2 times by the 1 in front will give us 2. Subtract 1 from the exponent will give us 2x to the power of 1. Alright? And that's exactly what we got using the long way around.
Wow. Okay, so would you ever have to do the long way? Or can you just do it the short
Yes,
way?
but they will tell you. No, they will tell you. The question will say, using first principles, or the principles of calculus, or something to that effect. Then you must use this
Okay, and
principle,
then you
the
have
long
to
way.
do the long way.
But if they don't say, you can use the short way. Okay, so let's take a look at that expression and let's differentiate it using the short way. There's a 1 in front of that x. So what you'll do is you'll multiply the 3 and the 1. It will give you 3, and then you subtract 1. So it becomes x to the power of 2.
2.
Alright.
Yeah.
However, there's a problem. Now you will, and I can almost give you money, I can bet money on this, you will get a question in the paper specifically asking you to find the first derivative, and they give you all these complicated expressions. Now there are 3 things that you need to get rid of first of all. Alright, I'm going to list them for you. Brackets.
Okay.
You need to get rid of all brackets, so you need to multiply brackets out. You need to get rid of all fractions where x, or the variable, is below the line. You need to get rid of that by using negative exponents.
Okay.
Alright? And then the third thing that you need to get rid of are roots. So in other words, we need to get rid of that square root, and we need to get rid of the x below the line. And to do that, we'll make use of that functionality. You should know this from exponents, where if that is a 2 and that is a 1, I can actually write this as x to the power of 1 over 2. Are you familiar with that technique? Of getting rid of the root signs.
Can you just go over it with me?
Well, basically what you do is you take the number outside the root sign and you bring it in as a denominator in the exponent. So if you have the cube root of x to the power of 4, you can write it without the root sign as x to the power of 4 over 3.
Over 3. Okay, alright.
Okay, so what we're going to have there is 4 over x to the power of a half. Because it is x to the power of 1 and the square root has a 2 outside. We don't write the 2, but it is there if it's a square root. Okay.
Okay.
And then we need to also take it up because step 2 says no fractions, where x is below the line. So that will then become 4x to the power of minus a half. You happy with that?
Yeah, I'm happy with that.
Alright, so now this whole expression, let me rewrite this expression. It will be x to the power of 3 minus 4x to the power of minus a half plus 3x squared. Okay.
Okay.
And then there's a 1 in front, so we'll multiply the 3 and the 1. That will give us 3, and then we subtract 1. So it becomes 3x squared. Then for the second one, we'll multiply minus a half with minus 4. Alright, and that will give us plus 2x to the power of, and then we need to subtract another 1 there. And that will give us minus 3 over 2. And for the last one, 2 times 3 is 6x, and subtract 1 to the power of 1. And that, for practical purposes, is your first derivative.
Okay.